Fireball. Woo-hoo. Yeah. Oh, is this? I never know if I never. Okay, welcome to the video after the quiz. Congratulations on finishing the quiz before the end of class. Or if you're at home watching this right now, I'm sorry. Okay, so this is 10.6 about secants and tangents and chords. Oh my. So we're going to talk about other angles around a circle now, not just angles that are on the circle or at the center, but angles that are at weird places like this or outside somewhere. Okay, so the first one is, what if we're talking about something like this, where the vertex of the circle is, the vertex of the angle is somewhere in the middle of the circle, not at the center. All right, so if that happens, we're talking about two chords that intersect. And when two chords intersect, like say we're talking about angle ABC, because there's of course 4 different angles in here that have 2 different measures. But if we're talking about angle ABC, that has a vertical partner over here. And those 2 vertical angles, I could draw them. If we're talking about ABC and its vertical partner on this side, those 2 angles, if you look at the interiors of those angles and kind of where they point and what they're hugging, one's hugging the one over here and one's hugging the one over here. It's the one I have drawn here in solid green. Those are 2 different arcs that have 2 different measures, but it turns out that this angle in here, and of course they're the same, the measure of this angle is just the average of those 2. Looks like what we just did with midpoints. But anyway, it's the average of these 2 arcs. So in this case, and I did this on Sketchpad, so these are kind of rounded values. But if this is 50.12 and this is 115, you add those up and divide them by 2, you'll get 82.56. And that's measure this angle in here. Likewise, if you wanted to find these angles, well, of course, if you'd found this one already, all you got to do is supplementary. But these are also, of course, the average of these 2 dotted arcs. Kind of cool. Okay, so here's some examples. There's 2 kinds of problems you're going to get with this. This one's pretty straightforward. If I want to find this angle x in here, of course it's the same as the one in here. Those 2 angles both equal simply 40 plus 84 divided by 2. I can show you the proof of this in class and why this does work out. Has to do with making those similar triangles here at GC and DF. We had a problem at the start of class last time that had to do with those similar triangles, if you remember. All right, so this is 124 divided by 2. So those measures are each 62. All right. And then this one is the same relationship, but now you're looking for one of the arcs. So we know that 152 plus y divided by 2 is supposed to be 111, so 152 plus y is really 222, so y is like 70, I think that works out right. Okay, now what happens if the vertex is outside? Notice how I named these, the last one was the interior vertex theorem, if it's just some random point in the interior of the circle. Here is, what if it's some random point on the exterior of the circle? And now I say it this way because this could be any combination of secants and tangents. So it could be 2 secants, like what we see here. This is a secant, by the way. It's like an extended chord. Or it could be 2 tangents, like we've seen before, the party hat kind of picture. Or it could be a secant and a tangent. So that's why it says any combination of secants and tangents. That will mean that the vertex is outside the circle. Okay. Almost the same equation, but the difference here is instead of adding and divide by 2, we subtract and divide by 2. So here this 41.86 is simply the faraway arc minus the closer arc. That will always be the greater one minus the smaller one because we want positive answers. And then take that difference and divide by 2. Again, if you really want a proof of that, I can do it in class. But how do you do this? All right, for angle z here, z is simply, you take the 112 minus the 41 and divide that by 2. Oh, this is going to be yucky. What is this? 71 divided by 2, which is, I guess, not too bad, 35 and a half. Same thing here. Now this one's drawn with a tangent and a secant. But if you look at the, extending this ray and you look at the angles that are inside the interior of that angle, the x is far away, the 48 is close. So if we take x minus 48 and divide that by 2, that result should be 23. So x minus 48 is 46, and x is 94. Okay. All right, so really that's all that's new in 10.6. I didn't do the 2 tangent one, although that's pictured here. The rest of this video and the rest of what you have in your notes is simply, like, up till this point, I thought it'd be a good idea, because this video is pretty short so far, around 5 minutes, to just kind of review all the rules in one place. So on the back of this page that you're looking at now, you should see, I think this is the top one, you're going to see all these rules. Some of them are surprising, some of them are hard to remember, so I thought this is a good point, because we're not learning any more rules of this type. The only other thing we're doing between now and the test is the equation of the circle, and that's totally on coordinates, and it's not really like this stuff, so it doesn't really go here. All right, so this little picture is kind of nice. It shows 3 relationships, actually 4 if I kind of stretch it, but if you show 2 tangents outside the circle, again, this is what people were calling the party hat. Not only those 2 lengths are the same, that was some theorem. Another theorem says that these things are perpendicular. That kind of shows you that part of the picture there. But because of that, because we have this kite here, of course, radius is congruent to radius. Because we have a kite here, and this quadrilateral has 360 degrees, and those 2 are 90, these 2 angles, this thing and this thing, those have to be supplementary. So another way to think about that is this angle outside here at the tangents is supplementary to the measure of this arc, because that's the same as this thing over here. So those make 180 right here between that angle and that arc. There's 180 in there. So there's a lot going on in this picture that you can actually use to remember. It's kind of nice. Other stuff on that page, if this is a biconditional, if a radius is perpendicular to a chord, if this is perpendicular, then those are midpoints. Sorry, that this is a midpoint and those are equal. Same thing in the arc. These 2 parts of the arc are congruent. This is like the midpoint of an arc, which isn't really a thing, but you get the idea. And the converse of that works also. If a radius strikes a chord at a midpoint, then it must be perpendicular. So that works. If the distance from the center to a chord is congruent to another distance from a center to another chord, then the chords are congruent. And if the chords are congruent, of course, then the corresponding arcs are congruent. Here's the intercepted angle theorem, which is just that an angle whose vertex is on the circle is half of the measure of the arc that's inside that angle. Here's a special case of that. That's also true if we're talking about one of those rays being a tangent ray. This is still this angle here. This was hard for most people to see. This angle between these 2 rays, this tangent and this chord, this angle is half the measure of this arc here. If you have a diameter and you connect it to any point on the circle like this, you will get a right angle, you get a right triangle. That's really a special case of this, of course, because the semicircle is 180 and this angle intercepts that semicircle. Extending this fairly quickly gets you to this idea. If you have a quadrilateral inscribed in a circle, opposite angles are supplementary. So 4 plus 2 is 180, and 3 plus 1 is 180. Here's one we just learned, that if you have a vertex in the interior of a circle in a random place, the measures of the angles there are the average, add and divide by 2, of the 2 intercepted arcs. Then if it's outside the circle, here's the 2 tangents, here's the 2 secants, here's a secant and a tangent. It's the far one minus the close one divided by 2. And that's pictured in all 3 of these. A little bit harder to see, I guess, in this one, especially when they don't extend this tangent. They don't have to, but if they don't extend it, it's harder to tell, I think, that this arc is inside this angle. But it is. It's in the interior. And that's it. Those are all the rules we're going to talk about. There's actually a lot of other mysterious and magical rules about lengths related to these things in circles, but sadly it's not part of our curriculum. So we're just going to talk about angles. And the last thing we have, next class, which is the class right after the quiz, we're going to talk about 10.8, which is equation of circle, and then it's review, then tests. So we're about to wrap up circles. See you then. The party is a many-sided polygon.